everyone. In this presentation, we are going to solve the problem in inductance. So in last video presentation, we have seen the basic concept of capacitance and also we have solved the problem in capacitance. The next basic element, energy storage element, especially in electric circuits, is inductance. So whose basic concept is store electrical energy in magnetic field, whereas capacitance which stores energy in electrostatic field. So inductance is also an important parameter like your capacitance. And inductance, we have seen a lot of derivations in electromagnetic theory. In case of capacitance, we solved and we have derived the equations for capacitance of 2 dielectric medium and 3 dielectric medium. Like this, in inductance concept, we have derived the equation for inductance in solenoid and toroid. So this problem, we are going to solve the inductance for solenoid. So in that case, the data given for the solenoid are number of turns and current flowing through the solenoid coil and diameter of the solenoid coil like this. So from this data, by using the direct formula, we are going to solve this problem.
Next, we see the structure or procedure to solve the problem in inductance. Our aim is to find out the inductance value and energy stored in the inductance. Step 1 is to find area, it is denoted by A. Step 2, it is to find out the inductance, which is denoted by L. And the final step, step 3, is to find the energy stored in inductance. Now we are going to see the given data. The data given in the problem are the number of turns, which is denoted by the letter N, which is equal to 2000, and the diameter of the conductor, which is given as D is equal to 5 centimeter. We are going to convert into standard unit, 5 into 10 power minus 2 meter, and the length, which is denoted by the letter L, whose value is 50 centimeter, and it can be converted into standard unit, 50 into 10 power minus 2 meter, and the current which is flowing through the conductor is taken as I is equal to 10 amps. Next, we are going to find out the area which is given in the step 1. Now we are getting into the step 1. Step 1 is to find the area whose formula is given by A is equal to pi by 4 D square. Pi by 4 into D is the diameter of the coil, which is given by 5 into 10 power minus 2 whole square. After calculating this one, the area is given by 19.635 into 10 power minus 4 meter square. And this is the value of A, which is obtained in step 1. Next, we are getting into the step 2. In step 2, we are going to find out the value for inductance. It is denoted by L, whose formula is given by L is equal to mu naught N square A divided by L, and this is the formula for inductance of solenoid. We all know that this is the construction of solenoid, and it consists of conductor or winding or wire, which is having n number of turns through which the current I is flowing. So now we have the formula for calculating the inductance, and it is given by mu naught N square A by L. Now we are substituting all the values in this expression, where mu naught is absolute permeability, whose value is given by 4 pi into 10 power minus 7. And N square is, where N is 2000, and by substituting these values n square, and A we have already found out in the step 1. Substituting this value 19.635 into 10 power minus 4 divided by L, where L is the length of that coil, so length of the solenoid, which is given by 50 into 10 power minus 2 meter. After substituting all those values in this formula, now by using the calculator we can calculate, we can reduce this, we can get the value for inductance is 0.01974 Henry, and this is the value of inductance we obtained in this step 2. Next, we have step number 3. In this step number 3, we are going to find out the energy stored in the inductance. We all know that the inductance which stores the energy in magnetic field. So energy stored in the inductance is given by E is equal to half Li square. Half Li squared, this is the formula for energy stored in the inductance. Whereas capacitor, which stores the energy in electric field or electrostatic field, whose value is given by half CV square. Now we are substituting the values in this expression. Half, we have already found the inductance value in step number 2. We are substituting this value in step number 3. 0.01974 into I, where I is 10 amps that we have in the given data, that value. So we substitute that value in this expression, and finally we get E is equal to, after calculating this by using the calculator, we got the value of energy 0.987 joules, where joules is the unit of energy.